Now, Pedro, can you share your slides? And
yes,
the presentation will be made by Pedro Zizek and Higor Amario. Dr. Higor Amario. Hello, Dr. Higor. Both
Hi.
are from the University of São Paulo. So you have 15 minutes for your presentation.
Okay. So I will start the presentation and Pedro will talk after me. Okay, the idea is to present some of the works we are doing in the BikeScience project. Next. Bicycle as a transportation mode is increasing around the world. There are a lot of bike share systems spread all over the world, and the cities are investing on the construction of bike lanes and in their cycling infrastructures. There are also several benefits, well-known benefits from using bicycles for transportation. Personal benefits such as physical and mental improvements for health, for the environment too, for noise and air pollution, with less traffic congestion, for example. But there is a lot of space to even more people adopt bicycles as a transportation mode. Next. So the BikeScience project started as a partnership between InterSCity and Sensible City Lab. We are using bike sharing data and another data related to bicycles to support evidence-based public policies. We have used data such as bicycle trips from bike share systems and travel surveys. We are also using information about the cycling infrastructures in the cities, information from points of interest, transportation stations and restaurants, and so on. Next. We developed a tool called BikeScience, which is written in Python using Python notebooks. And we are using this tool to analyze data from several cities, including Boston and São Paulo. We also have a partnership with some bike share system companies like Tembici and Yellow from São Paulo. We are using their data to make some analysis too. And we also have a partnership with the traffic engineering company from São Paulo. We are using data from the Origin Destination Survey, OD17, made in São Paulo, to make some analysis and suggest some improvements for the cycling infrastructure in São Paulo. Next. Here on this map, you have a screenshot of the BikeScience tool in Boston. So we have analyzed the main bike flows of the local bike share system. Here on the blue arrows, we can see trips that go from a location to another. The thickness of these flows represent the number of trips they carry. And the black dots are the stations through the city. So we found that only 1% of the bike flows in Boston carry 25% of the trips. So that this information can be used, for example, to suggest some improvements in the cycling infrastructure near to these flows. Next. The tool also provides some statistical analysis. For example, most of the trips in Boston are made by people between 22 and 35 years old. Next. We are also developing a web version of BikeScience to allow people that without knowledge on programming languages to make their own analysis too. This map shows São Paulo. The blue arrows are flows from a rectangular area to another. And here we have also the subway and train systems too. Next. This map shows the bike flows and information from the cycling infrastructure of São Paulo in orange and red. Next. The data from the OD17 survey has the origin and destination coordinates of the trips. So we are using a tool, an API called Graph-Hopper, to collect information about the bike routes for these trips. These trips also has a weight that represents a number of people that make these trips. Next. So here on this map, we have all the bike routes for the OD17. We are using this information to understand in what places there are more trips in São Paulo. We are using the trip weights and summing the weights in overlapping coordinates to get this information. Next slide. So here in São Paulo, in these places, there are highlighted, we have more than 4,000 daily trips on the black dots, on the west region, on the southeast region, and on the north downtown too. Next. We are also using the bike routes information to prioritize new cycling infrastructures in São Paulo. This map has the current bike infrastructure. Next. These bike lanes in green are those proposed for 2021. Next slide. And here are only the planned bike lanes for this year. The dark green, red lanes are those with more potential to receive trips from the citizens around more than 2,000 trips. The CET is using this information to as a criteria to prioritize the bike lanes that will be built first. Okay, so now Pedro is going to talk about another project we are doing on the BikeScience project.
Okay, thank you, Higor. I'm Pedro, good afternoon. I'll talk about the cycling potential index developed by our group. So the context and the motivation to develop this tool is the perception that São Paulo could have much more bike trips than it does. Initial studies shows that 65% of car trips are no longer than 6 kilometers, indicating that great part of these trips could be migrated to bicycle if proper conditions were established. Besides, there are local laws such as the BikeSP program that set goals for the bike usage in the city and proposes policies such as offering credits or financial benefits for citizens who migrate to the bicycle mode. Hence, it becomes necessary a deeper understanding of where these policies would have a greater impact. And after literature review, the factors that could impact most on using bikes for commuting are the trip's distance and slope, as well as the cycling infrastructure and number of accidents. Also, personal factors such as the age, gender, lifestyle, and car ownership can influence this potential. So one of the questions that our research aims to answer is what is the potential for travel migration from other modes of transport to cycling? And to answer this, our model considers three factors: the slope of a trip, the distance, and the age of the person doing the trip. And for each one of these three variables, the model calculates a value ranging from 0 to 1. And the final cycling potential index, or CPI, is the arithmetic mean between those three variables. The model considers those three attributes using a statistical analysis of the current bike trips in São Paulo using data from OD17. A continuous approximation is made that better approximates the distribution of these trips. So for instance, the trips distance of the trips made with bicycle by women in São Paulo are concentrated around 2 kilometers. And the second graph, we have the same continuous modeling for the cyclist age variable, already normalized between 0 and 1. And in the third image, we have the slope modeling that considers the sum of the slopes in 10 meters stretches and pondered by the degree of inclination. So the more steep it is, it will receive a worse cycling potential. Here we have a first example of a trip, and this one is a trip with a good cycling potential, so the value is closer to 1. And this trip has a good cycling potential because it's short, so it has 2.6 kilometers, and it's composed mostly by downhill and flat stretches represented by these blue and yellow colors. Next, we have an example of a trip with a bad cycling potential, so this a low final value. And since it's done by an older person and it's longer, so it has almost 5 kilometers, and it's composed by many uphill stretches. So we can see this trip is very hilly, and the uphill stretches are shown in red and black colors. So this trip would be hard to migrate to bicycle. To evaluate the fitness of our index, we are now conducting a user survey where the participants can evaluate 5 bike routes from their region. In this way, we can compare the best routes indicated by the users with the routes with better cycling potential calculated by our cycling potential index. And the next steps on this topic are, as I said, compare the survey responses to our index, evaluate the bicycle infrastructure planning, since with this kind of index, the city administration can direct investments to the regions with greater cycling potential, so regions that would benefit more from implementation of bike lanes, for example. And estimate migration from other transport modes. So how many trips are migratable that nowadays are made by car, by train, etc. And measure the impacts or the benefits that this migration would bring to the city. For example, decreasing the vehicle pollution emissions. Lastly, it's important to transfer this technology to the traffic engineering company that we are working with, so that the next mobility policies can follow this data-driven approach. We invite you all to answer our user survey and contact us in case of any questions. Thank you.
Okay, thank you. So, do we have questions for Higor or Pedro about BikeScience project? Oh, we have a question on the chat. ID Vab asked, okay, let me read and then I'll translate. So while you compare the route that's indicated by the user and by the index, your index, you will be mapping the reasons for the differences between what the user says and the index, or it will be just a mechanism to calibrate the model? Pedro, do you understand the question?
Yes, so thank you for the question. Yes, the idea is to use these answers to calibrate our model. So to see if our model is adherent to the general perception of the cyclists that already use a bicycle in the city.
Okay, so what the model will do after calibrate is that given a route in the city, the model will tell how easy or how difficult it would be for a person that's doing that route in another mode of transportation to change to the bicycle, right?
Exactly.
And then how do you think we can use that later to suggest improvements in the cycling infrastructure of the city?
So one of the studies we're conducting together with this cycling potential index is after evaluate the regions with greater cycling potential and compare with the regions with more cycling infrastructure. So we can find regions that could have much more bicycle trips, but doesn't have nowadays bike lanes or segregated lanes for bicycles.
Okay. And I guess that looking at that slide that Higor showed, the planned future, yeah, that one, that's the future bike lanes. You could also apply your model to these future bike lanes and to also give another prioritization, right? To paint in different colors the bike lanes that have a larger potential according to your model, right?
Yeah, so here, if Higor wanna talk also, but the colors indicate that only the number of trips that nowadays travel using these roads, and we can improve this prioritization, not only counting the trips, but also the potential to migrate to bicycle of the trips that use this.
Potential future trips, right?
Yes.
Yes,
So your trips are trips that are not yet done in bicycle, but could be.
Yeah,
but I think that these indexes could be used separately or together depending on the conditions, but both can be used to suggest places that could be more suitable to build the new infrastructures. And I think that the important thing is to provide these informations for those that will build the infrastructures to decide based on both or one of these criteria.
Okay, there's a question, interesting question from Thales Paiva. I guess it's for Pedro. How were these variables, age, slope, and distance, selected? Doesn't the weather conditions play an important role in the decision to use the bike?
Okay, so that's a good question. We mapped lots of variables that could impact on the cycling potential, and decided for these three because they are. We didn't want to give much importance on socioeconomics, since we want to analyze the city only for the physical characteristics, and since the cycling infrastructure that could be built doesn't depend on the time of the day, for example, or the season of the year, we decided to use these variables that are more constant in the regions and the trips evaluated. I think
Thales also asked about the weather. The thing is that the weather is not something that a person takes into consideration when deciding if this person will use the bicycle as a transportation mode for its life. It can be a something that he will consider on that day. If it's raining at that moment, then he might not go by bicycle. But for this particular index, it doesn't play a role because the weather is the same in the whole city. It can, any point of the city can rain or cannot not rain. If it were a city in which some parts of the city never rained and other parts rained a lot, then it could make a difference. But since the weather here is orthogonal to what Pedro is analyzing, they are, we can say they are independent variables.
Nice.
Okay. One last question by Zach Summit. Is that map of frequency of bike use painted in green coherent with the CPI of those routes? I imagine there's also correlation with the F times D parameter from the previous presentation. So Pedro, for example, the dark green there is a high potential for the existing trips, but your index is future trips. Is there a correlation between them?
We are using different kinds of information to build this potential on green. We are using only the trip weights, is a past information from the past. In the work that Pedro talked about, we are using another kind of information, and we do not compare it until now, these informations, but it is an interesting thing to do in the future too.
Yes, my opinion is that.
Okay.
Sorry. There will be a correlation since I imagine the regions more dense with more population have more trips and naturally more trips with good potential. So I imagine there will be this correlation between dense populated zones.
Okay. Lucas has a question, but Pedro will answer that asynchronously because now we need to move to the next presentation. Thank you, Pedro and Higor.
Thank you.
Pedro, take note of Lucas' question.